Okay, so let us start that we were talking about the distance vector routing in the previous class. That I told you that there are maximum number of hops that can be 15 because it leads to be an instability problem. Because if you see that you consider a case like this. Uh, so here, suppose if I have a node A, node B, and node E like that. So suppose if A and B are connected, so A sends its vector that it can reach B with this 3, right? With E infinity, because it doesn't know about E, that how it can reach to E, right? And once B shares, this is the table of B, that it has A with 3 and E with 2. So B shares its table with A, right? A comes to know that it can reach E via B, right? Once B shares its table with A, it comes to know that it can reach E via V, but unfortunately this link fails, right? This link fails and B has no route to reach E, and subsequently B has to update its table. So the updated table will be A can reach with 3 and E can be infinity, right? Because B cannot reach it, and once it shares, it sends this update to A. This doesn't reach A. Okay, it doesn't reach A, right? It doesn't reach A. So A is under the impression that it can reach E via V, but it is not so, because B has the link between B and E is not working. So in this
Sir,
way,
will B know?
huh?
Sir, will B know that E has got cut off?
Pardon, I am not getting what you are saying. Apurv, Ayush, what you are saying?
Sir, will node B know that the link between B and E has got cut off?
Yeah, we knows that is why it updates its table now. That A with 3 it has updated its table to E as infinity because it cannot reach E, right? So and there is another thing in this, that is the next node information. Let me just draw it properly, right? So there is, in the distance vector route, there are three things. One is a node that it can reach B, what is the cost, and what is the next node? Next node is B. Uh, Node, right? E, it doesn't know which node it should follow. So B, once it updates its table, right? B, once it updates its table, it cannot. This path doesn't exist. So B updates that A is 3 and E is infinity. The next node is A and no next node. So once it shares this table with A, right? This update failed to reach at A, right? This update doesn't reach A, so A still remains under the impression that it can reach E via V, and this update is not reaching to A, and suppose A, because it can be a periodic update also, and before that A shares its table with B, right? So then, as per the previous table, A can reach E via B if this link is not broken. So it can be, I can write like so initially A has this table that it knows that it can reach E via B, and unfortunately this link fails, and this updated information doesn't reach A, right? And by the time A shares its table with B, so what B understands that since this update is coming from A, okay, so that means B thinks that it can reach E via A. Okay, क्या आवाज कर रहा है रितेश? A can reach, B can reach E via A. So it updates its table that it can reach E via A. So it updates its table that A is 3, E is infinity, but it can reach 3 plus 5, E is 8, and it can reach via A. Next node is A, right? So this type of, and once B shares updated table with A, so this kind of instability will come, right? And this value will keep on increasing from 8 plus 3, 11 plus 3, 14. So like that, this cost will keep on increasing, right? As they change their tables, exchange their tables. And so there should be some value of infinity, right? What should be the value of infinity? So that is why it has been restricted to 15 number of hops, right? So are you following? That if suppose if this information failed to reach at A, that will create a confusion, and A will be under the impression that it can reach E via B, and once A shares its table that it can reach E via B, B feels that it can reach A via E via A, right? So that will create a confusion, and they will keep on, this value, this cost will keep on increasing. So there should be an upper bound on that. So that upper bound is fixed to 15 number of hops, so that puts the limitation of distance vector routing as an exterior routing protocol, right? So I told you that what are the difficulties in choosing them as a exterior routing protocol. Exterior routing protocols are those which exchange information between the two autonomous systems, right? Inside an autonomous system, there will be one routing algorithm, and between the two autonomous systems, the algorithm will be different, right? So the protocol based on this exterior routing protocol, path vector routing, is BGP. So BGP also works in the form of messages. Okay, there are three procedures: neighbor acquisition, neighbor reachability, network reachability, and there are four messages, right? So open message is used to open a relationship with the other router, right? We are talking about one autonomous system with another autonomous system. So this open message is being exchanged to open a relationship with another router, right? So depending on its engagement, the router may accept it or router may decline the request. So if the request is accepted, so that means they form one connection, right? And once the connection is formed, the routers keep on checking the status of their connectivity by sending this update message. Okay, so once, suppose this router sends an open message to this router, if this router agrees on opening a connection, it replies back with an keep alive message. So keep alive message is used for as an acknowledgement, right? So So it replies back with a keep alive message, right? And this keep alive message has two purposes. First is it is used for acknowledgement purpose, and it is also being exchanged to say that their relationship still exists. Right? From time to time, the router exchanges the keep alive messages with each other to say that their relationship still exists between them. Right? Update message is used when uh, when a router discovers a new path, so it sends an update message to the other router, right? And notification is to notify any error in the message. So that is what these are the four messages which are used by BGP, and there are three procedures: neighbor acquisition, just to open a connection with the neighbor. In this neighbor acquisition, open and keep alive messages are used. So it sends an open message. In return, it gets an keep alive message to say that their relationship exists, and a keep alive message is exchanged on a regular basis between the two routers to check whether the neighbor is available or not. So that is called as the neighbor reachability. The two routers will exchange keep alive message periodically to check the existence of their relationship, right? Network reachability is like whenever there is some update that how can you reach to a particular network, so that update will come in the form of network reachability means, so an update will be given, update message will be exchanged to intimate about how can you reach on a particular network, right? So these are the BGP messages. Marker says about these are used for this synchronization purpose, length of the message, type, version, my autonomous system, the details of the autonomous system the router belongs, hold time, that how long it is going to wait for the reply, like once if it is initiated an open message, how long it will wait for a keep alive message to or an acknowledgement to put the connection in the established state, right? So BGP identifier, optional parameters, right? So you can see that so BGP procedure, they open TCP connection, send open messages, includes proposed hold time, receiver select minimum of its hold time and that sent, maximum time between keep alive and update messages, right? So update message whenever they discover any new path. So AS path, list of AS to be traversed, next hop, कौन सा next hop होगा, multi access disk, that is basically what are the exit route in the autonomous system. So that information can be put in this messages, right? Update message, network layer reachability information, path attributes. As I said that it is based on a path vector routing. So here a path is to be mentioned, that which path the packet will follow. So that is what the AS path, list of AS to be traversed. So that makes it suitable for policy routing, right? So AS path enables routing policy, avoids a particular AS, security, performance, quality, number of AS crossed. Next hop, only a few routers implement BGP because it is not necessary that in the network every router is implementing BGP protocol. They may be using some other protocol. So in that case, they simply treat the packet as a normal packet. Okay, so they simply forward the packet to the next hop because it is not implementing BGP, so it will not check for that. So it will simply forward the message to the next hop. So those routers which are implementing this BGP will be responsible for this policy decision, right? Notification messages are used to identify any kind of error in the messages, like the header error, open message error, like the syntax and options not recognized, update message error, hold time is expired. Okay, so such errors are notified using the notification error. So within AS, router builds topology picture using IGP, means interior routing protocols, right? Router issues update messages to other router outside AS using BGP. So IGP means Interior Gateway Protocol, Border Gateway Protocol. Those routers exchange info with other routers in the AS. Routers must then decide best routes. Right, so this is about BGP, which is based on path vector routing, which is an algorithm for exterior routing protocol. Right. Next is OSPF. OSPF is Interior Routing Protocol. It is based on simply link state routing. Link state means the topology of the node, like the node is connected with other nodes. Okay, what is the link cost? Okay, what is the link cost? How many nodes it is connected? So it shows the complete topology is there with each node, right, in the link state. So, and in the link state, I told you that the updates basically are flooded in the network, right? So link state packets are flooded in the network, and to make sure that any one packet reaches at the destination. So the topology is stored as directed graph. Okay, so vertices or nodes, there are two types of vertices or nodes, that is router or network, right? The network can be, you can see here, right? So this is a sample autonomous system given over here, right? You can see there are different networks. Okay, there are different routers. Okay, connected in this, right? So this OSPF is a protocol which is based on a link state routing protocol, LSP, and this each node stores the topology of the network. So the topology is stored as a directed graph. So first of all, we have to make a directed graph. Then we find out the shortest path tree from that particular node. So here, to draw a directed graph, you should remember that there are vertices like routers, network, and there are edges like graph edge. Basically, to connect two routers, that can be a point-to-point link or connect routers to the network. So you can see here that it connects two routers. It's a point-to-point link, right? And it connects a router to the network. Okay, and there are different types of networks. You can see here some of the networks are referred to as the transit network. Transit network is one, that means the data can, you can see this network is a transit network, like the data is entering from this side and moving from this side, right? So it is a transit network, right? Is N11 also, network 11 also a transit network? Is network 11 also a transit network? Network 11, network 4 are also transit network? No, they are stub networks, right? Stub network means that ends over there. It is not, if it is not a transit network, it is a stub network, right? Transit means the packets are like N3, the packets are entering from all the through and they are passing through the network, right? So that is a transit network. What N4 is an example of a stub network, because it is not a transit network. Because here everything ends over here, right? So how do we make a directed graph? You see that this is a connection. This edge is a it's a bidirectional edge. Can be it can be represented with a bidirectional edge like this, right? So you just see that how do we represent. So you can see that R3 and R8, they are represented by a bidirectional edges, right? So this network N3, this N1, N2, these are all N11, N4, these are all stub networks, right? And this N6, N3, N9, they are all transit networks, right? So this N10 is a stub network. Fine. So first of all, we have to draw. इस type का एक example आपको end semester में आ सकता है कि draw the this open shortest path first, right? Take this as a shortest path tree and draw the things. So OSPF, first of all, it is what we do. We draw a directed graph from here. So this is what a directed graph of the sample autonomous system. In that we mark what is transit, what is stub, right? And these networks are going to connect with the other system, right? They are not part of the, they are connecting this autonomous system with the other autonomous system, right? And 13 and 14 and 12. So that is why they have been shown as a dotted line, right? Then we use Dijkstra algorithm to find out the shortest path tree. Okay. So next hop used in routing package. So first let us see that we choose in R6, right? We choose in R6 as the root node, and from here we determine the shortest path to reach all other networks, right? And then we connect it like this, so it resulted in a shortest path tree. Okay, you can see. So you will be routing data from R6 to other networks. What is the shortest distance, right? So it is a shortest path tree for router 6. You can draw it in this diagram. If you draw that, how can you reach R from R6 to R5, right? What is the minimum distance to reach to these networks, right? N3. So how will you reach? So there will be only a one path exists, just like if you remember that was a spanning tree. So this is what a shortest path tree. No closed loop exists. You can see, right? No closed loop exists. So only a single path exists. So this is what we do in multicasting. So when we multicast any data, any information, what we do between a source and a destination, because the destination stations may be scattered on different networks. So what could be the possibility? First of all, we have to draw a shortest path tree from the source, which can be as a root node, to all the destinations. Like how can we reach two different destinations on different networks, right? So we create a shortest path tree from the source node to all the destinations in the on different networks, and that resulted in a shortest path tree, right? And then we route the information. And as I told you in multicasting, uh, as compared to broadcast or multiple unicast, in multicast resulted in less load generation, because a single copy of the message is generated by the source, and it is duplicated at each branch of the tree, right? So as you can see that a single copy will be generated by the source, from the source, and it will be duplicated here. It will be regenerated at this node as this branch, so that the number of copies generated are less as compared to multiple unicast and multicasting, broadcasting. So this is about the SPF generation, OSPF, open shortest path first, based on this link state routing. There is another protocol that is based on, I can say that interior routing protocols. Interior routing protocols are two, that is distance vector and link state. So the protocol based on this is RIP, that is routing information protocol. और दूसरा है link state, means इस पे based है OSPF, just now we talked. And there is an ERP, exterior routing protocol. The example is, it is based on path vector routing. Algorithm is path vector, and example is BGP, right? So routing information protocol, I am not doing it, is very simple, that it is a hop count is given. Okay, so each node maintains a destination IP address with the number of hops, right? And then how many hops it will take to reach to a particular destination. So giving in Horizon में दिया हुआ है. So now the next is so this Wednesday we will have a quiz, है ना? Wednesday evening we will have a quiz. Second module. So I already told you that what is integrated service architecture. It is also called as an INTSERV. Okay, you will find presently it is outdated because it has been overtaken by differentiated services, DS, preferably known as DS. So as I told you, that quality of service, for providing quality of service over an IP, okay, there are two models proposed by IETF. One was ISA, Integrated Service Architecture, and another is the differentiated services. So though ISA is obsolete now, but you should understand that what ISA was. ISA, as you know, that the demands are increasing day by day to obtain to get good quality of service, right? With the increasing number of users, with the increasing number of user demands, we are getting a very 4G, 5G, right? We are at the doorstep of the 5G. So with such change in the requirement, so that there are many changes required, that in the functionalities, in the routers, right? So how we get a quality of service? So we will be discussing these two models, ISA and differentiated services. So basically we classify the traffic into two types: elastic traffic and inelastic traffic. I have already told you that the elastic traffic is one which can meet the demand even though it is delayed, right? Like email, though it is delayed, but still it meets the requirement of a user. While in elastic traffic, like if any real-time traffic, right, which is subjected to some delay, it will be useless to the user, right? Suppose if you consider a share bazaar updates, share market updates. So if a user is not being updated at the right time, if the packet gets delayed, the user has to bear the brunt of loss, right? Because of this. So that is inelastic traffic. So what are the requirements for inelastic traffic? That a throughput, delay, jitter. So you know that packet loss. Okay, so it demands higher throughput, minimum delay. Okay, minimum jitter. Jitter is what? The delay variation. Okay, packet loss, minimum number of packet loss. Require preferential treatment for certain type of traffic, right? So you want that one application which is highly important should be given a preferential treatment. So and in order to do that, it requires that the elastic traffic should also support the same thing, because elastic traffic can meet the requirement, but ऐसा भी नहीं होना चाहिए always inelastic will be given the preference, elastic will never get a chance, right? So a balance is required, right? What is the ISA approach? So ISA approach is basically that, first of all, how the ISA is implemented, right? ISA, the ISA provides information in the routers itself, right? It codes this ISA block which you will see, this ISA in a router. This approach is inbuilt in a router. Those routers which are implementing ISA, okay, will get this information in the router itself. Okay, so what are this in the ISA? See, there are two things. This portion is known as forwarding functions, right? All these functions are integrated in the routers, and these are called the background functions. So what is there in the background? You have a routing protocols, right, to take routing decisions, okay, to find out the shortest path, routing protocols, and then based on that the routing databases are updated. And at the same time, you can see here, okay, this diagram, there is a reservation protocol. What is the reservation protocol? RSVP. There is a reservation protocol named RSVP. Okay, so what it does, I told you earlier also that similar to what we face when we reserve any seat in a plane or a train. So depending on the availability, right, we get reservation in different classes, right? So if the resources are available in the network, an application has to say about their requirement in the beginning of the process, so that the resource reservation protocol reserve the resources. So depending on the requirement, that if it wants minimum delay, minimum jitter, minimum packet loss, right? So there can be different characteristics that a process can demand, that an application can demand, right? Some application are happy if suppose some packets are lost, they are not very concerned. Okay, they are only concerned that the delay should be minimum. Okay, so if some packets are dropped, it is not of their concern. So depending on their requirement, they request for the reservation of the resources, right? So once they request the resources, the reservation protocol checks the current engagement of the resources or the availability of the resources, and based on that it updates the admission control unit. It guides the admission control unit so that and also updates the traffic control database based on that. So if it is allowed, the admission control, so a new application has been admitted. Okay, this management agent guides the traffic control database. It is just a network management protocol, SNMP, okay, that controls the admission procedures, right? Based on once the reservation protocol gives a green signal that yes, we have the resources, the application can be allowed to enter with the requested things. Then the management unit will guide the admission control to input those. Okay, so based on, and the traffic control database is updated on that. So once the packet enters, this is what the packet enters from here, right? So here we have a classifier and route selection. So it basically, it is updated from the routing database. So here the packet is being classified to different classes based on the requirement of the application. A packet is classified in multiple classes, and based on that which particular class they belong, which particular service that particular class require, and based on that the route for that particular class is selected. And once it reaches over here, so this is a packet scheduler which determines whether this packet belongs to a particular class requiring a different kind of service, so it gives a quality of service queuing, or if it finds no, this is a normal application, or the resources are not reserved for this, nothing has come to us, so it provides a best effort queuing. So like that, this queuing is changed based on the class of the packet in which a class packet has been classified, right? If you see here, so congestion controlled by routing algorithms and packet discard. So whenever there is a congestion, the router starts discarding the packets. So they associate each packet with a flow, right? Flow, I told you that a set of packets originated from the same source to be delivered on the same destination requires similar treatment. They can be unidirectional or they can be multicast. Admission control. So for a new flow, OSPF provides quality of service based route, queuing discipline and discard policy, right? So how this reservation, basically how this traffic is being characterized by the algorithm, right? So you must have heard something about the token bucket scheme. Have you heard of it? टोकन बकेट, जैसे आप जितने पैसे लेके जाते हो उतने ही का दुकानदार आपको सामान देता है, राइट? इफ यू थिंक इन दैट वे. So here we have a bucket of size B bits. This bucket is a token generator which is continuously generating the tokens and putting in this bucket. So the number of tokens available in the bucket is like, means if the size of the number of tokens, like the how much bucket is filled, right? How many bits are there in the bucket? Based on that, if that size matches with the arriving packet size, the regulator allows the packet for queuing. Otherwise, it holds the packet. So router puts token into bucket at predetermined rate. Tokens can accumulate up to the bucket size. Okay, access token discarded. Then traffic seeks admittance to network. Once the packet arrives at the regulator, the router's queue regulator requests tokens equal to the size of the next packet. So once it gives the tokens equal to the size of this packet, okay, the packet is allowed to pass. Otherwise, if tokens are not available, packet is either queued or for transmission but marked as access, offered for later transmission or discarded, right? This is about a token bucket scheme to regulate the traffic. Are you following? That the first thing is that congestion controlled by the routing algorithm. So this is how the traffic is being characterized, right? How the traffic is being controlled. So for that, traffic control to avoid congestion, this is a token bucket scheme. Another scheme is that you must have heard of leaky bucket. Okay, so this leaky bucket scheme is that you have a busty flow, right? जैसे आप टैप खोलते हो तो पानी बहुत तेजी से आता है, but the size, the hole at the bottom of this bucket is of fixed size. So the water flowing out is of a fixed flow, right? So that controls the traffic. So as you are coming at 12 Mbps, okay, busty data, sometimes it is 12 Mbps, sometimes it is 2 Mbps. Okay, कुछ है ही नहीं कभी. But if you see from the leaky bucket, the output is always fixed. Okay, 3 Mbps. So this is how the traffic is being shaped. Okay, this is called as the traffic shaping. So there are three types of services offered by ISA: guaranteed service, that means it assures the data rate, it assures upper bound on the queuing delay, no queuing loss, real-time playback. Okay, control load means it is adaptive. So if the load changes, it assures that approximate behavior will be followed, but there is no upper bound on the queuing delay. There is very high delivery success, but there can be failures also, right? So if the load is limited in the network, there are two things. Actually, there are T and R fields. That is called as the traffic specifications, right? जब भी कोई भी एप्लीकेशन एंटर होती है ना, वो बताती है एंड ट्रैफिक स्पेसिफिकेशन एंड रिसोर्स स्पेसिफिकेशन. जब तक, what is the meaning of a contract? A contract means that you will be specifying that this quality you want, right? And this much unit. Suppose कोई एक कॉन्ट्रैक्ट है, आप कुछ खरीदना चाहते हो, तो आप क्या बोलते हो? You give your specifications. Okay, then the vendor assures the same specification and you pay the price, right, accordingly. But it may happen that if this specification exceeds क्योंकि ट्रैफिक कैरेक्टरिस्टिक्स क्या है, until and unless this traffic, I told you there are two types of traffic specification. One is like elastic traffic and inelastic traffic. As long as this traffic is in within the limits of the as per the contract, right, the queuing service is quality of service is being provided. But wherever it exceeds, the traffic specifications are exceeded, it provides the best effort service. Similarly, resource specifications, there are two bits, T and R specifications, traffic specifications and resource specifications. So based on that, what is the meaning of control load? Until and unless your flow is not very excessive, like the flow rate is maintained, okay, the data rate is maintained, there is no excessiveness until then. So with that, it assures that you will get the proper service. But if it is exceeding that, it will not guarantee that you will get the same thing, right? So otherwise, in that case, it will be a best effort service. So what is a queuing discipline? So if you see, queuing discipline is FIFO queuing. Generally, what we expect that, see, we are talking about the quality of service. So when we are talking about quality of service, we are expecting that some kind of a preferential treatment will be given to a high volume application or an application for real time purpose. So suppose there are different flows are coming to this queue, right, to the router. This is a queue. So if the router uses the FIFO queue, that is a first in, first out. So there is no partiality here. Everyone is treated in the same manner. But what is the disadvantage? The disadvantage is that there is no preferential treatment given, right? So even though some applications, some flow which belong to very like real-time traffic, they will be also treated in the same manner. So what is how does it modified? So here we have got a fair queue. So in a fair queuing, from different flows, right? From different flows, this is what the multiplex output. It takes the same number of packets from each flow. Okay. So it is addressed in a round robin system. So it takes from here 3 packets, from here 3, from here 3 from here, right? But this also has got a disadvantage, right? Some low volume application may not have 3 packets to send, right? Or a high volume application has many packets to send, but it is only able to send only 3, right? So it is further modified to a weighted fair queuing. So in a weighted fair queuing, is not here, weighted fair queuing. In a weighted fair queuing, what we do, we assign weights on each flow. Suppose this is a high volume application, so I have given 5, 2, 1. This is a very least. This traffic is, you can say, elastic traffic, and these are non-elastic traffic. So here this is a high volume and it is of higher priority. So I have assigned a weight of 5 to 1. So once this fair queuing, now it is modified to weighted fair queuing. So once this is operating in the round robin system, so it will take 5 packets from flow 1, because this flow is excessive. So it will take 5 packets from flow 1, 2 packets from flow 2, and flow 1 it will take only 1 packet, right? So this is called as a weighted fair queuing. Here you assign a weight to different flows depending on their requirement, and they are being queued and served based on that, right? This is about the fair queuing. So resource reservation protocol. Resource reservation protocol is named as RSVP. It is a unicast application. It can reserve resources in routers to meet quality of service. If your router cannot meet request, application informed. Like as I said, that if resources are not available, like a train reservation, if the train berth is not available, you will be getting the information that no availability, right, or waiting list or something like that. So if there is no availability, the application will be given as the best effort service. Multicasting is more demanding. Okay. So how this multicasting cope up with? This is very interesting. So suppose if every application demands a similar type of service, so how it is maintained? Because multicasting is a very tedious task. It is not very simple when you are implementing over an internet, right? So how does it save the day? That is like, suppose you are watching a match. Okay, match is being telecasted by Star Sports, DD National, and Sony Tennis Sports, right? So how does it save that every user is not using the same thing? Not only the Star Sports, some of them are using only, some of them are on Star Sports, some of them are on DD National, some of them are on Sony Tennis Sports, right? So like that, the users are divided. So this is how it shapes that some members of group may not require delivery from a particular source over given time, right? So if I'm saying Star Sports, only few users are needed. Not everybody is tuned to the Star Sports, right? So that is one thing. Second thing, that the quality of transmission. Suppose if the quality of transmission is HD, high definition, but most of the users are not having SD TV to watch, right? They are having only the SD connections. So they will only watch the standard definition, right? So so that is what it is. It gets reduced. That the load gets reduced in multicasting, right? So in resource reservation, the information in the routers are maintained about a reservation of a particular flow in the form of soft states. These soft states are basically updated dynamically, because you know, as the internet is a dynamic environment, things changes very fast. So set of state information in router that expires unless refreshed, and these informations needs to be refreshed from time to time. Okay, otherwise they will get expire. So how does it work? What are the characteristics of RSVP? RSVP can be used for both unicasting and multicasting. Unicasting means there is one source, one destination. But multicasting, one source, multiple destinations, that too on scattered over different networks. It's very complex. So here, the important thing is that the reservation is initiated by the receiver. Receiver initiated reservation. So receiver reserves the resources. So, and this maintains the information in the soft states, and it provides different reservation styles, like the wild reservation, and there are different reservation styles. Around 12 kinds of different reservation styles are available, and it is a transparent operation. Like there will be some users which are not using RSVP protocol, some routers, so they will be using simply providing the normal treatment. Okay, it is used for both IPv4 and IPv6, and you will see that this reservation is made by the destination. So destination sends a reservation packet towards the source, right? And during that course, it finds out it stores the information on the en route routers. It informs the information on the en route routers towards the source, right? And the reservation is made, and then the source sends the information back towards the destination, right? So so this is about an RSVP differentiated services we will do in the next class, and there will be a quiz on Wednesday, right? Anything to ask?
Sir, please upload the PPT.
Okay. So after Holi, I am expecting that you people will be offline available in the class, right? Because till Holi, I was not insisting, but after Holi, I expect that everybody should come back to the classes. Okay, most probably the classes will be offline after Holi, right? Thank you. And don't miss the quiz. Okay, it will be on Wednesday, 6 o'clock.